Hi guys, welcome. We're going to have a look at inequalities in the relationship with modulus and how do we solve questions like the ones you can see on the screen. These are from page 11 of your book. I'm going to start with D and then move on to E. And what I really want to show you here is that you need more than one skill to answer these questions. We'll see that D is better answered algebraically, easier to answer just by doing some algebra, whereas E is better to answer graphically or using the Cartesian plane. But I'll show you how to do both questions in both ways. Okay, so let's start with question D, which I will just zoom in on. Okay, so there are two possibilities here. Either 2x minus 3 is a positive number, so when we take the absolute value it doesn't change, or 2x minus 3 is a negative number, so that when we take the absolute value it becomes its opposite, which means we multiply by -1. So I'll show that in this way. Okay, so what we can see here is at the top we've got 2x minus 3 is greater than or equal to 4. That's what happens if 2x minus 3 is positive, or negative bracket 2x minus 3 is greater than or equal to 4. And if we solve the top one, as I show you here, we end up with x is greater than or equal to 3.5. It's relatively straightforward, just normal algebra, nothing complicated there. But if we solve the other one below, you have to just remember that if you divide by a negative number or multiply by a negative number, then you have to change the sign of the inequality. So just notice that at the end there it's shifted to x is less than or equal to -0.5, because in the previous step I divided by -2. Okay, here's the graphical version. The 2x minus 3 absolute value greater than or equal to 4, if I draw the graph of the 2x minus 3 absolute value, it looks like that V shape. It's got a y-intercept of 3 and an x-intercept of 1.5. You can find those by substituting x equals 0 to get the y-intercept, or finding what makes the modulus 0 to find the x-intercept. So putting 1.5 into the modulus gives us 2 times 1.5 minus 3, which is 0. So that's how I know what it's going to look like. Now we're interested to see when is this greater than or equal to 4. So I've drawn the line of 4 across in green here. And we just want to see the area that is above that line. So first of all we look at those intercepts, which seem to be at about 3.5-ish on the right. If we just sort of drop down, and as you can see here, and about -0.5 on the left. Now we actually know those values from our previous algebraic equations, so I'm not going to prove that here. Geometrically it'd be a bit tricky to prove. In any case, what we want is to be above the green line. We want to be bigger than or equal to 4. So I'll just, in yellow, shade in the part of the V that is satisfying the inequality. So we've got to be 4 or more on the right and 4 or more on the left. If we track down to the x-axis, that means we need to be 3.5 or more here, or 0.5 or less here. And so that gives us our final answer, that either x is going to be less than less than -0.5, less than or equal to -0.5, don't forget the equal, or x is going to have to be greater than or equal to 3.5. Which is the same solution as we got algebraically, but done with the Cartesian graph. Okay, next I'm going to move on to the other question and do it in the same way, algebraically and graphically, and we'll see which one is easier for that one. But for this one I certainly think algebraic is easier to work with.